really love that song. Okay, when we have common denominators, again, we are multiplying by a value of 1, so it doesn't change the value of the number. It just changes the appearance. It's like you're putting on a costume. Still you in there, you just look a little different. Okay, then when we add, we keep the like term. If I'm adding 9 21s plus 14 21s, I now have
23 21s.
23 21s.
Which is 1 and
It
2
is, but I'm
21s.
not going to do extra work that I don't have to. And if we ever needed 23 21s to do other things with, it would be most efficient to leave it as an improper. Don't change it unless you have to. Don't change it. It's improper. Improper. No, this is the way. This is easier to do. Maybe your elementary teachers that taught you wrong. Okay, 7/10 plus 8/5. Like denominator?
No.
Not yet. But what can 10 and 5 become?
10.
10 would be the most efficient. They could become 50, but that's more work. So we want to choose the lowest common denominator. We're going to multiply this one by 2 over 2. Then when you add them, you add the numerators, but you keep the like denominator. So we have 7/10 plus 16/10. So now we have 23/10. We have 23 of the like thing.
Or 2 and 3/10.
The next one, common denominator. We've got 28 and 4. What's the lowest common denominator?
28.
Since it's 28, I'm going to take the 1/4 and multiply by 7 over 7. Or did you try to reduce it after you? Did you try to reduce it? Okay, so after we multiply by 7 over 7, then we can subtract. We don't want to reduce until the very end. So I'm going to do 3 minus 7, 28. So negative 4, 28. Now, the next thing that I'm going to do, if you've worked ahead, you probably don't have on your paper this way. The next thing I'm going to do is what we have been doing in here, where in order to cancel things, because this does reduce, in order to cancel things, you have to factor it out. So on top and on bottom, like what number do you think I can cancel? I know some of you already know.
4.
Right, so what I need to do in order to cancel is I have to factor it, and factor means unmultiply. So on top, to get negative 4, I take negative 1 multiplied by 4, so I unmultiply that. On the bottom, I have 7 multiplied by 4. I unmultiplied it. That means I factored it. Once it's factored, then you can cancel the 4s. You can only cancel them if you factored them. You can only cancel them if you factored them. Otherwise, it's a possibility you might kill a buddy. Don't tell me that you want to. Okay, so if I have a negative number and I divide it by a positive number, what do I get? I get a negative number. So we have negative 1 over 7. Okay, the next 3, there are different ways of doing this. There are different ways of doing these. I'm going to choose the way that I think is the easiest for high school students in Algebra 2 to comprehend. But there are other ways to do it. If you've learned a different way and it works every single time, you might want to ask me about it, but that's totally fine. What I would do is I would get 2/3 minus 1/2. I would make one fraction on top first before we even look at this. What is this right here? Division, right? I'm going to do that division thing last. So all I'm going to do is combine the fractions on top. So to simplify on top, we need common denominators. What do 3 and 2 both go into?
Yes.
So we'll multiply this one by 3 over 3, and multiply this one by 2 over 2.
1/6.
So we get 4 over 6 minus 3 over 6 over 3/5. So I get 1 over 6 over 3/5. So over fraction bar, that means division. It means division.
There's a lot of division going on.
Huh?
There's a lot of division going on.
There is. So let's not divide that much. Instead of dividing by a number,
Multiply by the reciprocal.
you multiply by its reciprocal. So we've got like 3 division signs. I would stay with the main division sign. So I would read this as 1/6 divided by 3/5. But instead of dividing by, we're going to multiply by the reciprocal. So I'm going to still keep 1/6, and now I'm going to do times by 5 over 3. So we get 5 over 18. Does anything factor out of 5 and 18 that I could cancel?
No. Yes. No.
Well, 1 doesn't change the appearance at all, so. Yeah, we can factor out a 1, then we factor out a 1 again, then we can factor out a 1 again, and keep canceling. It's not going to ever change the appearance.
So we can never end factoring if we can keep factoring
Right.
out
That's
one.
why we don't. That's why we don't factor out the 1, unless absolutely needed. Okay, number 5. On top, let's find a common denominator. What is common for 8 and 4?
18.
8. So we're going to multiply this one by 2 over 2. It's negative 5/8 minus 6/8 divided by 2. Negative 5/8 minus 6/8 divided by 2. So negative 5/8 minus 6/8 gives us negative 11/8 divided by 2. Negative 11/8 divided by 2. Instead of dividing by 2, we're going to take negative 11/8, multiply it by the reciprocal of 2, which is a half.
That's so crazy.
You think you were wrong because it wasn't 15 and 2?
Nah.
Right. Big, huge common mistake would be people writing 2 over 1 here instead of a half. Huge common mistake. I see it all the time. Just have to take your time. If you say it out loud, negative 11/8 divided by 2, multiply by a half. Like if you say it out loud, sometimes it helps. So we multiply straight across, we get negative 11 over 16. That doesn't reduce. That's our answer. All right, last one. On top, we've got 5/2 minus 7/5. So our common denominator, 10. So I'm going to multiply by 5 over 5 and by 2 over 2. On the bottom, I do not have to have a common denominator of 10. I do not. I just have to have a common denominator between the two of these.
Yeah.
So 4 is currently over 1. So I'm going to multiply it by 3 over 3. So on top, we're going to get 25 over 10 minus 14 over 10. On the bottom, we get negative 2/3 plus 12/3. So we have 25 tens minus 14 tens. So now we have 11 tens divided by. On the bottom, we have negative 2 threes plus 12 threes. So we have negative 2 plus 12 threes. 10 threes. I'm saying that stuff weird on purpose.
Yeah.
You remember it.
It's weird.
Okay, so instead of 11 tens divided by 10 threes, we're going to take 11 tens and multiply by
3 tenths.
3 tens. So 33 over 100, and no, it does not cancel.
Easy.
All right. So we're going to break this section into 3 full days so that you have the opportunity to really learn it. I'm not going to overload you. It is the start of the semester. You have the opportunity, if you did not do so hot last semester, to cancel out whatever you did last semester, average it out, and get the credit that you need to graduate.
The semester's too cold. It started before.
Yes.
We already
Thank you. I
started
said the
this
wrong
semester.
word.
Yeah.
So right now, you're starting fresh. The worst thing that you can do is not turn in the first assignment, because you've already set yourself up for failure. You are average 17 years old in here. Average
I'm 16.
16 and a half years old in here, whatever. You're like almost an adult. Some of us are less mature than others, but you are age-wise almost an adult. Some of us. You can do your first homework assignment. Let's do it.
Yeah. New
Oh, I'm not
Oh,
ready.
it's
Okay.
monologue.
Addition with like denominators. Like denominators. Same denominators. Ready? Okay. We have the same denominator. So when we have the same denominator, we keep the same denominator and you add the numerators. We have 7 for x's plus 3 for x's. So now we have
10 for X.
10 for x's.
Whoa.
Well, is it reduced?
5 over
So 10 factors to 2 times 5 and 4x factors to 2 times 2 times x. They factor. And because when they factor, they both have a 2, we can cancel. Only if you factored it. Only if you factored it. Only if you factored it. Can you cancel? So now I have 5 over 2x. There was this thing that we did last week where we had exclusions. Where you take the denominator of the original and set it equal to 0, and this one we divide by 4, and x cannot equal 0. And we look at the denominator of the new answer, 2x equals 0, so x cannot equal 0. Is this different at all?
No.
Are the denominators have the same restrictions? Same restrictions? Same restrictions? I need an answer here. Are these numbers different at all?
It appears not.
Okay, so then you do not need any extra x cannot equal 2. So this is our final answer. Say that again?
We canceled the 2. We don't need to put.
Is that what x equals?
No.
It's not a variable? Good question. I had the same question the other class. The 2 that canceled out is not a variable. It's the variables that affect the bottom becoming 0. 2 can never be 0, so it doesn't matter.
Yeah.
Okay. All right. So look at this next one. Before we even do it, what can x not equal?
-6.
Negative 6. You have set it equal to 0 and solve it. So now we'll go ahead and solve it.
Oh,
2x minus 5 over x plus 6. So I did the numerators, 2x minus 5, and I put it over the common denominator. Can I factor anything out of the top? Is there a GCF? It's a binomial. Is there a GCF? Is there a GCF in the denominator? So I cannot factor anything. This is the answer. What about any restrictions? Do the restrictions change? They're the same, so we don't need to write anything extra. Okay, there's 4 of them.
Yeah.
Take a moment.
You try.
You try. You try.
You try.
You do it. You have lots of space. I've left you lots of space. You can use up all that space if needed. have to factor it. So 3 is what times what? Yeah, or 3 plus 1, you can just write that as 3 times 1. 3 times 1. Now you can what do you got? So is the 4, I mean, is the x on the bottom, or is it just off to the side? Okay, I just couldn't tell the way you wrote it, so just make it obviously like draw a line over, but yeah, that's right. Okay, that one's right. 2 plus 1. Do you factor?
If you do 2
You're
of
doing it in
those,
your
you
head.
get one of those.
We're doing 2x squared plus 2. You cannot add an x squared with something that doesn't have an x squared. So you have to write it out, 2x squared plus 2. And there is something that cancels, but it's not like that. Okay, so let's find out what number 2 is. You can factor out of 3. So like 3 times 1 and 3 times x squared. So like 3 8 minus 5. Just 2x squared plus 2. These are not original. 2x squared plus 2. All right, you've had plenty of time. Everybody in here should at least have number 1 and 2 done. There was so much time to get those first 2 done. 8 minus 5 over 12x, 3 over 12x. Some of us forgot to factor it though. Some of us forgot to go one step further. 3 is the same thing as 3 times 1. And 12x is the same thing as 3 times 4. Oh no! 3 times 4x. So then once you factor it, you can cancel out the 3's. One over 4x. And make sure that it is obvious that the 4 and the x are in the denominator together. All right, number 2. Easily should have been able to do 2 plus 1 over 3x squared. So 3 over 3x squared. I walked around and saw a lot of you had that done excellent, but then it does factor and cancel. So on top, 3 is the same thing as 3 times 1. And on the bottom, 3 times x squared. So if you can factor those numbers out, they can cancel. So we get 1 over x squared. So far, all I've canceled is numbers, so I don't need to worry about the denominator restrictions changing, because I haven't canceled out anything that has an x. Next one, 4 minus x. Yeah, 4 minus x. 4x, I mean minus x. Over x minus 2. And on top, 4x minus x is 3x. Over x minus 2. Some of us have that problem. I saw some interesting answers. So on top we have 3x. On the bottom we have x minus 2. Nothing factors out of the bottom. It's just x minus 2. Nothing factors out. So this is the answer. And the last one, some of us added together things that are not like terms. 2x squared plus 2. If you're skipping steps and doing it in your head, you might make silly mistakes. 2x squared plus 2 is not something I can add together. They are not like terms, so I have to leave it. Does anything factor? On top, a 2 comes out of x squared plus 1. And on the bottom, we have x squared plus 1. So what can factor out of the bottom?
X squared plus 1.
What can factor out of the
1.
bottom? A 1. So that the x squared plus 1s can cancel. Now, did we cancel out anything that had x's? So we might need to check our restrictions. So I'm going to do x squared plus 1 equals 0 to see what the restrictions would be, and I get x squared equals negative 1. What happens when I square root a negative number?
Oh, no.
It's imaginary, so there really aren't any real restrictions here. So there aren't any. Yes, so x couldn't equal an imaginary number, but it really doesn't equal an imaginary number anyway. All right, we have one more example and one more practice question to do, and then we will be done with notes for today. Finding the least common multiple. The least common multiple is kind of like finding the common denominator. It's kind of the same process, only it's going to look more complicated because we've got x's and stuff. So I'm going to give you a couple of quick examples that are just numbers, just review of least common multiple. So the least common multiple is if you started listing all the multiples of 3 and all the multiples of 9, what's the least number they have in common? So 3 is like 3, 6, 9, 12, 15. You know, when you count by threes. And 9, so it'd be like 9, 18, 27. What's the smallest number they have in common? 9. So the LCM of 3 and 9 is 9. It is going to be a bigger number. It's not going to be a smaller number. They both have to go into it. So if we have the LCM of 5 and 7.
35.
35 is the LCM of 5 and 7. The LCM of 4 and 3.
12.
12. How about the LCM of 4 and 6?
24.
No.
12. Come on.
So if you start thinking about your multiples of 4, you've got 4, 8, 12. 6 is 6, 12, 18. 12 is the lowest common multiple. Now this gets a little tricky when you look at the next examples. This is what we are doing. This is what we're finding, but it's going to be more tricky because this is all trinomials and binomials and stuff. So I just have like a step-by-step process. You just want to write down the steps and do it this way every time. It should work. First step is factor each expression. So factoring, if you are still not knowing how to factor, when I say factor, if you still do not know, it is very important that you learn this. If you would like a student tutor to work with you during study hall for however amount of time, I have people that I can set you up with tutors. I have people that I can set you up. You can tutor for free. You have to know how. But I have like 30 of them.
30? Oh.
And I have people who are in like higher level classes that can tutor you if you need help with factoring. Okay, so factor each expression is first. Let's do that. The first expression, what? 4x squared minus 16.
Just take out 4.
Always, first step, GCF. Take out 4.
X squared minus 4.
Is that factored all the way?
Yes.
No.
What?
So x squared minus 4 is a difference of squares, so we have to factor it to x plus 2 and x minus 2.
We were close.
Oops. Second one is 6x squared minus 24x plus 24. Is there a GCA? Okay, so we take out our 6. We have x squared minus 4x plus 4.
You go farther.
It can't.
X minus 2.
Okay. And you know what? I'm actually going to choose to write it out just for what I need it for. I mean, if my directions were just factored, I would write it as squared. I'm going to choose to write it out. Okay. Now, really, I haven't technically factored this all the way because 4 factors. 4 is what times what?
2 squared.
It's 2 times 2. And 6 is 2 times 3. All right, my step 2. Right. What the expressions have in common once. Right? What the expressions have in common once. I am going to write my third step over there and then we'll actually do it. So write what the expressions have in common once, and then my third step is write everything else. Okay. So we're going to write what they have in common once, then we're going to write everything else. All right, so the LCM. What do the two expressions have in common? What's something they have in common?
2 and x minus 2.
Okay, 2 and 1 x minus 2, right? That's all that they have in common. So down here I'm going to write a 2. I'll just write green. 2. And I'm also going to write an x minus 2. I am leaving some space on purpose. Now, after we write down what they have in common, we don't, like I circled 2 2's, you're only writing it once, okay? Now what we're going to do is ignore the stuff I circled, let's write everything else. So just going through here, I didn't circle this other 2, so I'm going to write that one.
Can we just write 12?
We will. I didn't circle the x plus 2. I didn't circle that 3. And I didn't circle that x minus 2. So all the stuff I had not circled originally, I went and I wrote everything. I guess I could write a 4th step to simplify. So when I write my LCM, I'm just going to multiply 2 times 2 times 3 and write 12. And then the x minus 2 and the x minus 2, I'll write that squared. And then the x plus 2, I'll just write. You do not need to FOIL all that back together. That would be way extra work that we don't need to do. No. That's a total waste of time. For what we're going to use this for, we're not going to want to multiply back together. What? Some of you may have been able to look at the factored step and saw the 4 and the 6, and we had just done that. 4 and 6 have 12 as their LCM, so you can probably figure out the number by itself. It just gets a little bit more confusing when you have all the binomials. So if you follow these steps, it'll work. If you can figure it out with shorter steps, that's fine. Let's do one more. Take a moment, start factoring it.
A minus B and parentheses. No, A plus B.
That's just x cubed. It's not a binomial.
I don't have to.
No, you're thinking of like difference of cubes where there's like a subtraction or an addition sign in between. There has to be two terms. Just, what's 5x cubed factor? 5 times x times x times x. How about 10x squared minus 15? What comes out of that?
5x.
Squared.
2x minus 3. So now, what do they have in common? 5x. That's part of the LCM. But you only write it once. What is the other stuff?
X squared, parentheses, 2x.
So then our LCM is 5x to the third, parenthesis, 2x minus 3. Okay, so for our assignment, it's a worksheet, and I want to show you it, and then I'll pass it out. At the top is finding the sum or difference, just like we did. At the bottom, then we have the LCM, the last thing that we did. And then when you flip it over is what we did last week. Total review. So there's some multiplication, there's some division. If you had trouble with that last week, make sure you get questions, answered. You could start with this part first if you wanted to. At the very bottom is a review over the graphing with the asymptotes. You may need to pull your notes back out if you've forgotten some things, but we will have a test over this entire chapter, and it'll be over this stuff too. So just because we took the exam with it on there doesn't mean you'll never see it again. So it will be on your test that will be coming up.